Okay, look at this limit a power sin x minus 1 by x cos x. Okay,
Mm.
so now let's try to break this into limits which are known to us. Okay, it is a
Mm.
regular format of limits. So, for example, we know sin x by x, right? We
Mm.
know a power x minus 1 by a power theta minus 1 by theta or a power x minus 1 by x. You know that, right?
Mm.
When x tends to 0, right? So what we are doing, we have cos x here, we have nx here. Basically, what we want, a power sin x is there, right? We want sin x in the denominator. Okay, so that's what we do. We multiply both numerator and denominator with sin x. Okay, sin x, sin x. So what we will do, what will happen? This part will become, this limit will become ln a, right?
Mm.
Okay, you remember this, no?
Yes, sir.
Okay, so this part will become sin x by x, that is fine. This is 1 by cos x, so that's how we are breaking this. Okay, so now look at this. 1 plus x square plus 3x whole power 1 by sin x. We know when x tends to 0, 1 plus x whole power 1 by x is e, right?
Yes,
One
sir.
when r x tends to infinity, 1 plus 1 by x whole power x, right?
Yes, sir.
So either case. Now we have this one here. So what we do? The power also, if it is 1 by x square plus 3x, then this would have been e. So what we do? Because at the same time when x tends to 0, x square plus 3x also will tend to 0. Right?
Mm.
Okay, so what we are doing? 1 by x square plus 3x, and then we are this 1 by sin x is there, right? We are multiplying with x square plus 3x, both numerator and denominator. Okay, ma?
Mm.
Okay, so then this entire part will become e. Okay, and then we should worry about this one, x into x plus 3 by sin x. And then again, x by sin x will again become 1. Right, sin x by x by sin x will again become 1. We'll be left with only x plus 3.
Yes.
Right. So
Yes.
then this becomes e power, this is 1, this is 1, and this is 3. That is eq. Okay.
Mm.
Okay, so now here is saying what he has tried to apply LH rule here. What is wrong in this? Okay, what is wrong? He's saying whenever we are applying LH rule, right, it should be in the 0 by 0 format.
Mm.
Here, basically, this is not in 0 by 0 format. That's what he's trying to say. Okay, so these are different forms of um, indeterminate forms. Okay,
Okay.
why these are indeterminate forms? So, for example, 0 power 0. Anything power 0 is 1. 0 power anything is 0. Right. But if it is 0 power 0, we are not clear. What exactly is this?
Mm.
Agreed. 2 power 0, 3 power 0, these are all ones. Okay. But
Yes.
if it is 0 power 0, we cannot clearly see. Clearly
Okay.
say. Okay. Similarly, 0 power infinity. Anything power infinity is infinity, generally. Right.
Mm.
Okay. So, for example, 2 power infinity, that is actually infinity. Okay.
Mm.
But 0 power in 0 power anything is actually equal to 0.
0.
Okay, so that's why this is
Indeterminate.
indeterminate form. Okay,
Yes.
okay, so 0 by 0. We cannot, so these are firstly in all the indeterminate forms, right? The base form is 0 by 0 and infinity by infinity.
Mm.
Every other form we will try to get that in this form so that we can apply LH rule. LH rule we can apply this case directly. Okay, differentiate numerator and denominator, differentiate numerator and denominator. But what we will do, we try to bring other cases in this format. Okay,
Okay, sir.
so for example, in this case, sin x power x, this is again 0 power 0, right?
Mm. Yes, sir.
0 power 0. So what we do, we'll assume this as some y. Okay, y equals to sin x power x. Okay, then what happens to ln y? It becomes x ln sin x, right?
Yes.
Okay, so this is in the form of what is ln 0? Ln 0 is, you know this function, right? Ln 0 is minus infinity, right?
Yes, sir.
Okay, this is in the form of kind of 0 into infinity. So what we do, we'll write this as ln sin x. This x, we'll send it to the bottom. by 1 by x. Okay?
Okay.
X tends to infinity, ln sin x tends to x tends to 0, ln sin x tends to infinity, 1 by x also tends to infinity. Agreed?
Yes, sir.
Okay, now this we have converted this 0 power 0 format to infinity by infinity. Agreed? This is what we have done.
Yes,
We
sir.
got this in this format. How did we do this? ln y. Okay, obviously, what we want it for y. If I are able to calculate limit of this y, then we will express y as we are looking for y, not for ln y, right? So
Yes,
y
sir.
is e power of whatever value of this one. Okay?
Okay, sir.
Okay, so now this we can freely differentiate numerator and denominator. Okay?
Mm.
Okay, see here, numerator is differentiated 1 by sin x and ln sin x, right? 1 by sin x and differential of sin x minus cos x. 1 by x is minus 1 by x square, which is nothing but x cos x by sin x by x. Okay? Sin x by x anyway, we know it is 1 and x cos x is 0. 0 by 1 is 0. Okay, so what should be our y? This y should be our e power 1. Understood?
Yes, sir.
This is ln y. ln y we got it as 0, right? So y should be e power 0, which should be equal to 1. That's why
Yeah.
the limit is actually equal to 1.
Yes, sir.
Okay?
Understood.
Okay. Now, you remember differentiability, right? Is this
Yes.
differentiable here?
No, sir.
It is no, because the function is not smooth.
Hmm.
Here, left side, there is one, when you approach from left side, the slope is different than from approach from right side. Okay?
Oh, yes, sir.
Left side, when you are approaching, what is the slope? If you differentiate this, it is 2x, right?
Hmm. Yes, sir.
Okay. So, this slope is different than this slope. Okay?
Yes, sir.
Now, this one, it is not differentiable here. Okay?
Hmm.
And this one, it is not differentiable here. It is not differentiable here. Everywhere else, it is differentiable. Okay?
Yes.
So when we are talking about the continuity, as long as left hand limit, right hand limit, and value of the function is same, it is continuous. But when you are talking about differentiability, left hand slope and right hand slope, left hand value, right hand value, everything should be same.
Same.
Okay, it should be continuous as well as
Differentiable.
as well as differentiable. Okay.
Hmm.
Okay, so now you know the basic things. When constant function, that means the function is not increasing or decreasing, right?
Hmm.
Y
Yes, sir.
equals to c, let's say for example. So that's why the slope is neither increasing nor decreasing, and slope is constant, which is equal to, which is flat, that's why it is 0. So that's why we are saying d by dx of a constant function is actually equal to 0.
No.
Right. And earlier we derived d by dx of 1 by x. How did we derive? 1 by x plus h minus 1 by x by h, whatever we did, right?
Hmm. Yes, sir.
And then we evaluated the limit, we got this.
Hmm.
Okay. Similarly, we can evaluate these limits also. Okay. You know the basic, this thing, d by dx of x power 1 is n into x power n minus 1. How did we get this? If n is an integer, okay, later we'll extend this for non-integers also.
Hmm.
For now, if it is an integer, you know this formula, right? A power n minus or z power n minus x power n. We can write this like this,
Yes.
right? If you just expand this, everything will get cancelled. Only these two terms will be remaining if you expand the right hand side, right?
Yes.
Okay. So now, what is the limit that we are talking about? Uh, if uh, if uh, if this is the function and f, what is f dash x? F of z minus f of x, z minus x, when z is approaching to towards
Yes.
x, right? We know
Yes.
this is the format, right?
Yes, sir.
Okay. So then what happens to this one? This we can write it like this, right? Z power n. Okay, if f of x is what? F of x is x power n. So f of z is z power n, right? Minus f of x, which is x power 1 by z minus x, which is nothing but this, right? Because this by this is actually equal to this. Now we can directly substitute z equals to x, which will get then x power n minus 1, then again x power n minus 1. All terms will become x power n minus 1. How many times? N terms, right?
Hmm.
So that's why we are getting an x power n minus 1. Okay.
Okay, sir.
Why exactly x power n derivative is n x power n? This is the simple proof. Okay, this applies. You understood this, no?
Yes,
But
yes.
here, what we have used that these n's are integers.
Mm.
Okay, because these n's are integers, we are able to break this into these two factors,
Yes.
right? And we use the regular definition, original definition of derivative. What is original definition of derivative? The
f
slope
of
of
x plus h
the
minus f of x by a.
right. So this is nothing but the slope of f of x is what you are saying. What is
Yes.
z? Z is some number which is away from x, so that is f of x plus h minus f of x by, again, the difference between
Into
y2
minus
minus
x.
y1 by x2 minus x1 is what we have done. Okay, ma?
Mm. Yes, sir.
Okay. So now later you will see why this is valid for non-integers also. For now, you just believe that this is valid for all integers also. Okay.
Okay.
So the basic derivatives we can do. Okay.
Mm.
Now, the constant doesn't matter. We generally bring out the constant, right?
Yes, sir.
Why it doesn't matter? You can actually do it yourself. Okay. So again, d by dx of cu. We just do the derivative like this. Okay. F of x plus h minus f of x by h. Then this c anyway will come out. Only we will be left with this. Okay, ma?
Okay, sir.
Okay. We generally derivative of addition of two functions. We can do the derivatives and add. Okay. As long as both are differentiable at all the places where we are talking about this. Okay. Okay. So how do we verify this? So if u plus v is a different function, if you assume this is a different function, then what is the derivative of this? U plus v whole power x whole of x plus h minus this one. Let's say if this entire function is some g or something, g of x plus h, which is this, minus g of x by h, right?
Yes, sir.
Okay, we can just rearrange and take this and this together and this together, we get this, which is nothing but this, what is this piece? This is nothing but derivative of u of x. This is nothing but derivative of v of x. That's why we are getting this. Okay. By the same logic, instead of plus, you can put minus and you can arrive this rule. Okay, ma?
Yes.
Similarly, you can apply this for multiple sum of multiple functions. Okay, as long as each function is differentiable in the place that we are talking about. Okay.
Mm.
Okay, so he's talking about horizontal tangent. What does that mean? The derivative should be equal to zero, right?
Yes, sir.
Okay, so now exponential is a different class of function. Okay, exponential function. So for example, e power x, it is, what is the derivative of e power x?
E power x.
E power x. What is the derivative of a power x?
A power x minus.
Okay, a power x ln a, right?
Mm.
Okay, wait. Derivative of a power x. Okay, so this one. What we are doing? A power x plus h minus a power x by h. Agreed?
Yes, please.
F of x plus h minus f of x by h. Right? We can write this as like this. Right?
Yes, sir.
Okay. Now a power x. We are still taking a power x common. We are writing it like this. Okay. Now limit h tends to 0. You remember this number. Right? What is this? ln x or
Yes, sir.
ln h. Right?
Mm.
Sorry, ln a. Agreed?
Yes, sir.
So you remember this, right? So for example, a power x minus 1 by, sorry, by x. What we did, we just differentiated, you differentiated numerator and denominator, right?
Yes,
A
yes.
power x ln a by 1. Okay? This is nothing but a power 0, which is 1 ln a.
Yes, sir.
Okay, ma? So this is ln a into a power x. But okay, so this one we have used LH rule. Okay, but
Okay.
without using LH rule also you can prove this. Okay.
Mm.
Okay, so this we drew the graph of this function, right? You
Yes,
remember
yes.
e power x minus 1 by x we got it as the a power x minus 1 by a, we got it as ln a, etc., etc. Okay,
Yes.
so now the beauty of these functions is, okay, he's doing a power x, which is some constant times a power x. Okay, This is some constant, right? H tends to 0. So this is not, there is no variable here. This is a constant number, right?
Yes, sir.
Okay, because h is tending to 0, and either this, if there is a limit, then this should approach some number, right? Whenever we are talking about a limit, that means we are talking about some number. Okay, either this is in the 0 by 0 format, either the limit exists, that means this is approaching some number, or the limit doesn't exist, right? So
Yes, sir.
now here, with other proofs, you can say the limit exists and it is approaching some number. Okay. And it is approaching some number means that should be a fixed number. It cannot approach two different numbers. Okay. So
Yes, sir.
what does that mean? The derivative of a power x is some number into a power x again. Okay. So what does it also means is the derivative of the slope of this function is actually directly proportional to this function, value of this function. Agreed?
Yes,
D
sir.
by dx of a power x is some constant into a power x. Okay? That is the beauty of exponential functions. What is an exponential function? The slope is actually proportional to the value of the function.
Okay.
Okay? So, in the case, so e power x is one special case in this. Why is it a special case? It is not only proportional, it's actually equal.
Hmm.
Okay? So, here the constant of proportion is actually 1 for e power x, which is fine, right? We are talking about ln a. Instead of a, if you put e, we will get ln e, which is nothing but 1, right?
Yes, sir.
Ln e to the base e is nothing but 1. So, e power x is one special function of among all this, right? Among all these, see, these are all a power x's.
Okay.
Okay? Sorry, yeah, a power h minus 1 by h. Okay, this is what he is drawing. Okay. So, if a is e, we are approaching that number 1. Okay, ma?
Okay.
Okay, so now so that's what he's saying. E power h minus 1 by h, which is equal to 1. So that's why d by dx of e power x, which is e power x, which is the constant is actually equal to 1 in this case.
Hmm.
Okay, so that's the beauty of this number e. Okay, ma.
Okay.
Okay, so that's why the exponential functions we don't differentiate like that of these powers. Okay, x power n is the differentiation is different from a power x. Okay, ma?
Okay, sir.
Okay. Now, similarly, the product rule also. You know this rule, right? You keep
Yes.
one function separate and differentiate other one, and keep the other one separate and differentiate the first one. Okay. So,
Like
but how did I
u
get
v
this?
dash. So that
What
only, right?
what ma?
You like keep u constant and do v dash.
Yes,
Then
yes. UV dash plus VU dash.
hmm.
Right? So, but how did we get this? We got it like this. Okay, UV is a separate function. What is UV of x plus h? That is this. Okay, f of x plus h minus f of x by h. Right?
Yes, sir.
Then we added this part and subtracted this part again.
Hmm.
Okay, to this part. Why are we doing this? Because we want to take this one together and this one together. Okay, this one together, u of x plus h, we taken this common and we wrote it like this, and this one we wrote it like this. Now again we are taking this piece common and we are writing this and this. Okay,
Okay.
okay. So u of x plus h into limit this one plus v of x plus h into limit of this one. What is limit of this one? This is v dash. And what is this one? This is u dash. Right? So,
Okay.
so u of x plus h into v dash, v of x plus h into u dash. Okay?
Yes, sir.
Okay. In short, we are able to get this. Okay?
Hmm.
Now, you know this one also, u by v. V u dash minus u v dash by v square, right?
Yes, sir.
Okay, so now this also similar derivation is there. You don't need this. Okay, you know how to derive higher order derivatives also. Yes, ma?
Yes, sir.
Okay, so these all derivatives you can do. Okay, u by
Okay.
v is there, u by v is there, u by v is there. This is also u by v. Okay, this is u v and u by v. All these ones. Okay, you need to be little careful. Okay,
Okay.
you need to be little careful. Then, if there are three functions, what you do? This taken two at it, one and two, then remaining you can break it again, right? V and
Yes,
W
sir.
you can take together, then U and this entire piece, and this entire piece you can break it together, or you can just multiply this one. You just multiply
Okay.
this one, then this function, this will become two functions only. Okay, ma?
Okay, sir.
So, derivative is the rate of change, this all you know. In speed acceleration, this you know, this you would learn in physics also.
Yes, sir.
First derivative is speed and second derivative is acceleration, right?
Yes, sir.
This is not needed. Okay. So derivative of sin x is cos x. How did we get this? Sin of x plus h minus sin x by x. F of x plus h minus f of x by h, right? Sin of x
Yes.
plus h, we just expanded this, and we took sin x cos h minus sin x, which is nothing but sin x into cos h minus 1 plus this one. Okay. Then we have broken this down, sin x into cos h minus 1. You remember this one, right?
Yes, sir.
Okay, so cos 0 is 1. This piece, right? And this piece also you remember. So just directly substituting, you are getting cos x. Agreed?
Yes, sir.
So basically, sin x derivative of sin x is cos x. Similarly, you can do the derivation for other functions also. Okay, ma? You understood this process, no? I think you need it in board. For board exams, they might ask you to do derivative from first principles. Okay?
Okay.
First principle means you have to derive the rules basically. Okay?
Okay.
All these rules, trigonometry functions, what you do, you just you write it as f of x plus h minus f of x by h, and then you just expand. And you expand and you use the derivatives from the first principles. Okay,
Okay.
ma? Agreed. So
Yes,
you
sir.
remember this one, no? Cos h minus x 1 by h. How did we get this as 0? Because we wrote it as 1 minus cos theta is 2 sin square theta by 2, like that. You remember that, no?
Yes, sir.
Sin theta by 2, and there is an extra sin theta by 2, something like this. So that's why this becomes 0. Okay?
Okay, sir.
Okay. So these are all functions you can do. And derivative of tan x. How do you tan x? Tan x, you can write it as sin x by cos x and u by v function, because you have
Okay.
derived already sin by cos, right? See, for
Yes.
example, okay, d by dx of sin by cos u by v, v du minus u dv by v square, right? That's what you have done.
Yes, sir.
Okay, secant x also you can write it as 1 by cos x and do the same derivative. Okay, ma?
Yes, sir.
Okay, so these all derivatives you can do. Okay.
Okay, sir.
Okay, you try to finish off your those books. I think KSET or boards. Okay.
Yes, sir.
Now you know the chain rule also, right?
Mm.
What is chain rule? If dy by dx is there, you can write it as dy by du into du by dx, right?
Yes, sir.
Okay. So for example, this is actually a composite function, right? In fact, there is a function x, there is a function x square, there is a function 3x plus 1, right? So
Yes.
this one, if you input this one, we get x square, right? If you input here, we are getting this one, right? Now, if you
Yes.
are inputting this one here again, you are getting this one. So there are a lot of composite functions here. Okay. So very basic of this, we assume this as u, then becomes y equals u square. Okay.
Okay.
Now what we do, dy by dx, you differentiate this with respect to u. Dy by dx, what we will write it as? We will write it as dy by du and du by dx, right? And what
Yes.
is dy by du? It is obviously 2u, and then du by dx. You remember this? You remember this, no? The chain
Yes.
rule. Okay, very good. So chain rule is mostly for this composite functions. In fact, most of the functions that we see are composite functions only. Okay.
Okay.
So this one, what you do? We derive outside inside. We go from outside and we go to inside, right?
Yes, sir.
Okay, we don't touch this. We do for cos, and then we go inside and do the remaining part, right? Now, what happens to d by dx of e power u? We outside inside again. E power u again du by dx. Okay. So, for example, e power kx, what will happen? E power kx and d by dx of kx, which is nothing but k e power kx. Okay, ma?
Yes.
Okay, so this also you know. All these things you can do. Okay.
Yes, sir.
And skipping this. Okay. So another interesting thing is implicit differentiation. How do we do this? This is implicit differentiation. What we do this? We do 2 by dy by dx equals to 1. Right?
Yes, sir.
You remember this, no?
Mm.
Okay. So for example, this one, how do you do? 2x plus 2 by dy by dx equals to 0. Right? Very good. This all you can do. I'm skipping this. Okay. This is interesting. Okay. What is an inverse function? Inverse function is a reflection with respect to this line y equals to x, right?
Yes, sir.
Okay, so if there is a line y equals to 2x minus 1, the reflection is this one. This is inverse function. Okay, so if f of a, if this is a function, okay, if f of a is b, then obviously on this function f of b should be equals to a. Okay, that
Okay.
is one part of the story. Okay, see here, f of a equals to b, f of b equals, sorry, f inverse of b should be equal to a. That is one part of the story. Another part of the story is this pink line is there, right?
Mm.
Okay, so the slope of this one. Okay, what is the slope of this one? F dash at a.
Yes.
Okay, f dash at a. Whatever is the slope. Let's say the slope is some 5. Okay,
Mm.
now that is f dash at a. Okay, now the slope of this inverse function, that is this yellow line. Okay, first of all, the yellow is inverse of blue one. Agreed?
Yes, sir.
This slope and this slope, the slope at b, should be related. Agreed? Because
Yes.
we are inverting this function. This point should become this point, right? So
Mm.
if there is this point, then the slope, the point is just, we are just inverting the point, right? AB is becoming BA. Obviously, there must be some relation between the slope here and slope here. Okay? What is the
Okay.
relation? The slope just, see, this is the slope and this is the slope, right?
Mm.
Whatever the slope of this becomes 1 by slope of this is here. Okay? So
Okay.
what does that mean? F inverse slope at B. What is that? That is nothing but 1 by of F slope at A. Okay?
Okay.
Can you see this? F inverse slope at B, this red line slope is nothing but 1 by slope of this blue line at A.
A.
Okay? Okay,
Mm.
but this is at B. This is at A. Agreed?
Yes, sir.
Okay, graphs of inverse functions have reciprocal slopes at corresponding points. What are the corresponding points? A, B, and B are the corresponding points.
Point.
And just remember this statement. Okay, they will have reciprocal slopes. If the slope is 10 here, this should be 1 by 10. Okay.
Okay, sir.
Okay. Now with this, we do lot of derivatives of lot of inverse functions. So, for example, sine inverse x. How do you do derivative of sine inverse x?
So derivative of sine inverse x.
Sine inverse x. This is what we'll use this one. Okay.
Okay, sir.
We'll use this method. Okay. Sine inverse x. Okay. Sine inverse x. The slope should be the reciprocal of sine x at some point. Okay. If
Mm.
sine x equals to y. Okay.
Yes, sir.
Sine x equals to y. What does that mean? Sine inverse x equals to sine inverse y equals to x. Okay. If the
Mm.
slope of, if you know the slope of this one, right? The slope of this one should be 1 by slope of this one. Agreed?
Yes, sir.
Agreed, no?
Yes, sir.
That's what we will use now.
1 by root 1 minus x square.
Right. Where is that? Thing? Okay. So I think this one. Right. Ah, F inverse. F inverse is what? What we are doing, sine inverse of u. Okay.
Mm.
Okay. So F inverse slope is what? F inverse slope is 1 by what is the slope of f dash? At which point? At whatever is the corresponding point. That's why
Mm.
we are getting 1 by under root 1 minus x square. Understood this?
Yes, sir.
Or otherwise, say for example, y equals to let's say sin x. Okay.
Okay.
Okay. So what you want? Sin inverse y equals to x. We want the slope of this one, right?
Yes.
We want the slope of this one, the x whatever. We want the slope of this one at a particular point. Okay.
Hmm.
We can actually do some implicit differentiation also here. Okay. So okay. So here what is it doing? F inverse. What is F inverse? Sin inverse x. The derivative of sin inverse at x. Okay. So obviously, what we have to find, this is 1 by f dash, the slope of sin x at f inverse x. Agreed?
Yes.
Okay. We know f of a equals to b. Okay. And f inverse slope at b, right, is 1 by f dash slope at a. Okay.
Okay, sir.
Slope at a. So that's what is slope of our original function at a. Okay. So here sin inverse x equals to b. So what we are looking for sin inverse x. Okay.
Yes, sir.
Sin inverse x, and what is our f inverse is sin inverse x. Agreed.
Yes,
F
sir.
dash, which is nothing but cos at sin inverse x. Okay.
Hmm.
Okay. F dash at a. Agreed.
Yes,
Cos
sir.
of sin inverse, which is nothing but under root 1 minus sin square sin inverse x. Agreed.
Yes.
That's why we are getting this one.
Okay.
Just give me a minute, ma. Okay. Understood this, no?
Yes, sir.
Okay. How we got 1 by under root 1 minus x square. Or otherwise, let's say sin inverse x equals to y. Okay. What does that mean? Sin y equals to x, right?
Yes, sir.
If we let's try to do implicit differentiation. What does that mean? Cos y dy by dx should be equals to 1. Agreed?
Hmm.
So dy by dx should become what? 1 by cos y.
Yes, sir.
Okay. That is 1 by under root 1 minus sin square y.
Hmm.
Agreed? Which is nothing but 1 by under root 1 minus x square. Because sin
Okay.
y is x. Okay. So that's how we got dy by dx as 1 by under root 1 minus x square. We did the same thing in slightly different format. Okay.
Hmm. Okay,
We did
sir.
the same thing. Agreed?
Yes, sir.
Now by using chain rule, if it was instead of x, it is some u, you can further differentiate du by dx. Agreed?
Hmm.
Okay. Similarly, tan inverse x. You can do this. Tan inverse x, you can assume it as y. Tan y equals to x. Then you do implicit differentiation. That is one part of the story. Or otherwise, you can do it like this also. Okay?
Okay, sir.
Okay. So tan inverse x, whatever the value, let's say tan inverse the slope at B. Okay, that should be equal to 1 by the slope of tan at A. Agreed?
Yes.
If tan A equals to B. If tan A equals to B, tan inverse the slope at B should be equal to 1 by tan slope at A. Okay. So what does that mean? Tan inverse slope at X. Okay. Tan inverse. So tan inverse. What is tan A? Which is nothing but tan inverse B. Right.
Yes.
Tan A. So what is A? A is nothing but tan inverse B. Right.
Yes, sir.
Okay. Okay. So that's what we are doing here. The slope of tan is secant square. Where do you want to find slope of tan? The slope of tan is secant square, right?
Yes, sir.
And what is this value A? Which is nothing but tan inverse of B. Okay, so in this case, which is nothing but tan inverse of X. Agreed.
Yes, sir.
So in this case, here, F inverse, this X is B, and what is A? A should be F inverse of X, right?
Yes, sir.
Okay, so that's why we are taking tan inverse. So secant square of tan inverse is nothing but, we can write it like this, right? Secant square 1 plus tan square, we can write it. So tan square of tan inverse X is X. Agreed, ma?
Yes, sir.
So the important point that you should remember is slopes of inverse functions are reciprocals at the corresponding points. Okay, all this now you can derive. Okay, derivatives of sine inverse, cos inverse, secant inverse, tan inverse, all of this. These are very important. Okay, you do these derivations once. Okay,
Okay, sir.
you should be able to do all these derivations. Okay, you should be able to do all the derivations once. Okay, I'll send you this book also. Just this is very important for integration also. Okay, that's why
Okay,
I'm
sir.
emphasizing this. Derivatives of inverse functions is actually very, very important. Okay, now, uh, where did he? I think he did not draw the graphs. Oh, okay, I think he drew the graphs. Okay, so now you know sin x graph, right?
Yes, sir.
Sin x, it looks something like this, whatever, right? Okay, now, first, earlier we discussed when a function should have inverse, obviously the function should be 1, 1. Agreed?
Yes, sir.
Because if a function is like this, if you try to do inverse, there are two y's for the same x. If you try to invert, then you will get two x's for the same y, which is not possible. Right?
Yes.
Agreed.
Yes, sir.
F inverse y1 should be so f inverse of y1 and f inverse of y2, both you will get the same value, which is not possible. Right? Agreed. If you try to do inverse of this, then you might get something like this or something like this, where for the same x, you are getting two different values of y, which is not even a function. Agreed?
Yes.
So, okay, so for example, f of x equals to x square. If you try to invert this, you get a graph like this, right? Okay, something with respect to y equals to x. But this is not possible, right? Here, if we cannot call this as a function, right? This part x square
Yes.
equals to y, we cannot call this as a function. Sorry, y square equals to x. Why? Because for the same value of x, we are getting two different values of y. Agreed?
Right. Yes,
Okay.
sir.
So that's why what we do when we are doing inverses of these trigonometric functions. Okay. What we do, we'll fix a piece of the original function so as to make it 1, 1. Okay. That
Okay, sir.
means as long as it is continuously increasing, there is only one value of y for so this is 1, 1, right? As long
Yes.
as x is different, y is different. Okay, so we take not the sine inverse, we take the sin x graph. Okay, I think we did not draw the sin x graph here. Okay, doesn't matter. Okay, sin x graph, as long as we are taking the graph from minus pi by 2 to pi by 2. Okay, this is definitely 1, 1. It is continuously increasing. Okay, but if you take something before that or after that, it is not 1, 1. Right? Because two
Yes.
different values of x will get the same value of y. So we are restricting the domain to this part, and whenever we are talking about inverse, we talk about inverse for this point only. Okay, for this piece only,
Okay.
not the entire sine graph. Okay,
Hmm.
so that's it. Can you see sine inverse? The range is minus pi by 2, pi by 2. Why? Because sin x we are restricting from minus pi by 2 to pi by 2.
Perfect.
Okay, So now if you try to invert this, you remember the inversion process, right? The diagram.
Yes,
Okay.
sir.
Are you convinced if you invert this, you will get this graph? Just convince yourself.
Yes, sir.
Okay, you will get this graph, no?
Hmm.
Okay. So you just need to flip it or do whatever, right? I told you, no, how to find the inverse.
Yes,
Okay, you
sir.
rotate it, you flip it, and finally you'll get x in terms of y in terms of x.
X.
Okay. Okay. So whatever it is there, you just need to flip the paper and turn it around some 90 degrees, then you will get this graph. Okay. So now, so what we are doing, we are actually restricting the domain from minus pi by 2 to pi by 2. Understood, no?
Yes, sir.
Okay. So similarly, cos x, this is the graph. Okay. Ideally, cos x would have been something like this. Okay. Something like this. But we want to keep from 0 to pi. Okay.
Hmm.
Or, see, 0 to pi. 0 to pi so that it is continuously decreasing here. Okay.
Yes.
Okay, to make it 1 1. Why we are doing this? Why we are restricting? Because to make it 1 1. Because otherwise the inverse function doesn't make sense. Okay, ma?
Hmm. Yes.
Okay. So now what do you have to do after the class? Try to, by not looking at the graphs. Okay. You
Hmm.
know, just try to plot all the 6 trigonometry functions, sin x, cos x, tan x, secant x, etc., etc., and all the inverses of those. Okay.
Okay.
Okay, so by trying to where first you have to see where you want to restrict the domain. Okay, then
Hmm.
like this, then you convince yourself where to restrict the domain. Okay, and then graphically try to invert the graphs. Okay,
Okay.
that is very important. Okay, so now this secant inverse. If you try to invert it like this, if you try to invert, you will get a graph like this. Okay,
Hmm.
but you convince yourself. You have to draw this after the class. Okay. You have to draw
Okay.
all the 6 trigonometric functions and their inverse graphs. Okay.
Okay.
Okay. Now, secant inverse, if you can see, the slope is always positive. Agreed?
Yes, sir.
Okay. So, in fact, this slope is always positive. This slope is always negative. This slope is always positive. Likewise. Okay.
Hmm.
Okay. So, now, secant inverse, that's why when you find when you do the entire derivative, you will get this one. This is a mod of this thing. Okay. Derivative of secant inverse x is 1 by mod u into u square minus 1. Okay. So the why this mod u is there is because we are forcing this piece to be positive. Okay. When
Okay.
u is greater than 0, this is anyway positive. Okay.
Hmm.
When u is less than 0, we have to make it positive. Okay. We don't need this mod u in other cases. You just seen that tan inverse is always positive. Right. 1 by 1 plus u square is anyway positive. Okay. Sin inverse x, you just see in the graph. No, it is always positive.
Yes,
But
sir.
here there is nothing u outside. Okay. So this is anyway always positive. 1 minus the square root of a number is always positive and 1 by some positive number. Right. Cos
Yes,
inverse
sir.
is always negative. So this is also, you can also see cos inverse is negative. Cot inverse also is negative. This is negative. But secant inverse, there is a u outside. Okay. How do you ensure that this is always positive slope? By using this mod. Okay, ma?
Yes, sir.
This is important. Secant inverse of when you do derivative, it is not just u. It should be mod u because we
Okay.
want the slope to be positive. Okay.
Hmm.
When u greater than 0, that is anyway positive. When u less than 0, to make it positive, we are doing this. Okay. See, look at the graphs once again. Secant inverse is always positive, equal secant inverse is always, slope is always negative. Agreed, no?
Yes, sir.
Cot inverse is always negative. Okay.
Understood.
Okay. So, but what you have to do? All those functions and there you have to derive all the derivatives of inverse functions as well as plot the graphs of the functions and their inverses. Okay,
Okay, sir.
because this you need multiple times in integrations also.
So derivative of just the function or their inverse as well?
Inverse also.
Okay.
Okay, so the inverse, at least do the implicit differentiation like what I had done now.
Hmm.
Ideally, you should be you should do this way as well as the implicit differentiation. This is what I had done now. This one.
Okay, sir.
Okay, this way and this way. Okay. Okay,
Okay, sir.
slope is slopes are reciprocals. The way slopes are reciprocals, no? This one. Okay. First you have to plot the graphs of both the function and the inverse. Then you have to derive the derivative of the function and the inverse. Okay.
Okay.
Function derivatives means from first principles. Sin x
Hmm.
plus h minus sin x. That one. Okay.
Yes, sir.
Using first principles only. Okay.
Okay.
And this one from this principle. Okay.
Hmm.
Once you do all of this, no, because these are all formulas we need in integrations. These are
Okay.
super useful formulas and integrations. Okay.
Okay.
Okay. Once you do this, okay, uh, please try to finish that because we need to cover hyperbolic functions also. You don't have your hyperbolic functions, no?
Sir,
Any
for 12th?
for 12th you don't have, no? For in
No.
11th it was there hyperbolic functions.
Yes, sir. It was there.
It was there in 11th.
Hmm.
Okay, we need a bit of those also for integrations. Okay,
Okay.
so then there is something called related rates. Okay,
Hmm.
there is something called related. So, for example, if you do volume of SPR is 4 by 3 pi r cube. Okay,
Hmm.
let's say if R is continuously changing, then volume also will be continuously changing, right?
Yes.
So, for example, you are inflating a balloon. Let's say it's a spherical balloon. Okay,
Hmm.
when the radius is increasing, its volume will also be increasing, right? If
Yes,
the
sir.
radius is fixed, volume is fixed. But radius is increasing, volume will increase at a greater rate. Agreed?
Yes, sir.
Okay. So when radius is increasing, volume will increase at a greater rate. So how do you depict mathematically? It is dv by dt equals to dv by dr into dr by dt. Okay. Rate of change of radius is dr by dt, and rate of change of volume is dv by dt. And this rate of change of volume and rate of change of radius are both related in this way. Okay.
Okay, sir.
Okay. So for example, in this one, uh, okay. Now can you tell me this? He's saying dy by dt. You're pouring water in this at the rate of 9 feet cube per minute. Then how fast is your height rising? Understood.
Hmm.
In the beginning, the height will be rising faster. Agreed. When
Yes, sir.
as it is going to the top, the speed should get reduced. The rate should get reduced. Now, how do you relate this and this?
dv by dt and dy by
dy
dt.
by dt. How do you relate this and this? That is the question.
So, sir, dv by dt is equal to dv by dy into dy by dt.
Very good. Okay. Very good. Excellent. Now, what is dv by dy?
dv by dy.
Hmm.
It is volume with like change of volume with respect to y.
Now, with respect to y. But how do you get that? Okay. So volume of a cone. What is volume of cone? 1 by 3 pi r square h.
R square h.
You
Yes.
remember, right? Volume of cylinder is 1 pi r square h. Cone is one third of the cylinder. 1 by 3 pi r square h. Okay.
Yes.
Now, let's take at a specific instant. What is let's say this is green cone. Okay. What is the radius of this green cone? It is x. Okay.
X.
What is h? Height of this cone? Y.
Mm.
1 by 3 pi x square. Y is the volume of this green cone. Right?
Yes, sir.
When the cone radius is x, the height is y, and pi r square h, 1 by 3 pi r square h is this one. Okay.
Yes.
Okay. Now with time, this y will change and this x will also change.
Yes, sir.
Agreed. With y will change, x will change. But x and y are related. Agreed.
Yes, sir.
X and y are related. And how are they related? Because if this is 5, this is 10. Okay, it is already. Okay. When x is increasing, y will also increase, right?
Yes, sir.
When x is 5, y is 10. When x is 4, y should be equal to 8. When x is something, y should be equal to twice of that something. Agreed?
Yes, sir.
Okay, so y will in this formula, y will write it as 2x then. Okay,
Okay.
agreed. Y is 2x or x as y by 2. Both
Mm.
are both are same, right?
Yes, sir.
then we are expressing this volume entirely in terms of x or in terms of y. Okay, that's how we'll get dv by dy. Okay, what is the goal here? We want to express everything in terms of, we want to express volume in terms of either y or x. If what is asking when the water is 6 feet deep, is asking dv by dy, right?
Yes, sir.
Okay, so that's what we have done. We expressed everything in terms of y. Okay, x is y by 2, right?
Hmm.
Now dv by dy is what? Y by 12 into 3y square. And dy by dt anyway he is given. Or he is asking. Dy by dt is given. Dy by dt is what he is asking. Okay? Okay. Now look at this. Uh, this one, this angle is pi by 4. Okay? At a specific instant. And the angle is increasing at the rate of 0.14 radians per minute. Okay?
Hmm.
Then what is the, how fast is this balloon rising? Okay, ma?
Okay, sir.
Okay, so uh, initially the angle will rise very fast, right? As
Yes,
the
sir.
balloon goes up and up, the increase in angle will become slower, right? Now what we
Yes,
have to do, we have to relate this this theta and this y and this distance whatever. We can use this also. We can, but we have to. He's given d theta by dt, right? Is
yes, sir.
given this. What we have to find? Dy by dt. So that means what? We want d theta by dy into dy by dt. Right? That's what we are looking for.
Yes, sir.
Agreed? D theta
Yes,
by dy we have to find. Okay. And dy by dt is what he is asking. Okay.
yes, sir.
Dy by dt is what he is asking, but we need d theta by dy. Agreed? So
Hmm.
basically what we have to do, we have to relate this y and theta. How do we relate y and theta? Tan theta equals to y by 500. Agreed?
Yes, sir.
Tan theta equals to y by 500. So basically, if you differentiate d theta by dy, what you will get?
Y by 500.
Y by 500 is tan theta. Okay.
Hmm.
Now, what we want d theta by dt, which is nothing but
So,
if you differentiate this, what you'll get? Secant square
we
theta
can
d theta by
theta.
dt equals to dy by dt. Agreed?
Yes, sir.
Y is expressed in terms of tan theta, right?
Hmm.
What we want? We want dy by dt. Okay? Dy by dt, if y is expressed in terms of tan theta, we can directly do, right? Dy by dt equals to secant square theta into d theta by dt. Agreed?
Yes, sir.
Understood, no? So basically, in all these related rate problems, no, we would be given one rate. Okay?
So,
Some
sir,
rate
the theta is equal to pi by 4. Oh, never mind, sir.
that we are calculating here, no, towards the end while calculating.
I didn't see it was there in the question.
Hello, can you see here?
Yeah, yes, I understood.
So d theta by dt, this is what he is already given, 0.14. Secant square, pi by 4, we have used it here. Right, secant square of pi by 4, which is root 2 whole square. Okay, ma?
Okay, sir.
Okay, we have used it here. So basically what we have done, we are given some rate. Okay?
Hmm.
We are asked to find some other rate. Okay?
Okay, sir.
So basically what we have to do, we are asked dy by data, sorry, we are asked dy by dt.
Yes, sir.
Okay, we are given d theta by dt. Okay, so if we are able to express y as some theta, then this is done, right?
Yes, sir.
Dy by dt equals to, then dy by dt equals dy by d theta into d theta by dt. Okay, for this what we need? We need y in terms of theta. Agreed?
Yes, sir.
Okay, so related rate, basically this is dy by dt is given, d theta, so this is given, this we have to find, these two we have to relate. How we will relate? We relate with this theta. Okay,
Hmm.
and luckily we found a relation between this y and this theta. Okay, in the
Okay.
earlier case, what we have to find? We are given volume, rate of volume. Okay, and we have to find dy by dt. Okay,
Yes, sir.
okay, so basically what we have done, we expressed volume as function of y. Okay, dv by dt equals to uh, dv by dy into dy by dt. This is what we have done. Agreed?
Yes, sir.
Okay. Or otherwise dv by dt equals to differential of this with respect to t. Agreed?
Hmm.
That's what we are doing. So whatever that is one rate is given, we have to find other rate. So we have to find a way of expressing some relation between this v and y, or in this case, this y and this theta. Okay, ma?
Yes, sir.
In this case, what is given? This fellow is approaching this one. This fellow is going this one, and this one is given ds by dt. Okay. Now he is asking dx by dt. Understood?
Yes, sir.
Okay. So this one. So this is at a distance of, is saying x is at a distance of 0.8, y is at a distance of 0.6. Okay. At that instant, the distance is increasing, ds by dt is increasing at the rate of 20. This is already given. Okay.
Okay, sir.
Then what is the velocity of this one? That is dx by dt. Okay. He has given dy by dt is already given. He is approaching at 60 miles per hour. Dy by dt is given. Dx by dt is what we have to find. We
Okay.
are given ds by dt. Okay.
Hmm.
Okay. So this is a right angle triangle. So basically we have to relate this and this and this. Right. We have to relate s. We have to write s as a function of y and
Right.
x. Y and x. So what do you do? X square plus y square equal to s square. Right. We know that. Right.
Hmm.
X square plus y square equal to s square. So we are just differentiating. 2s ds by dt equals to 2x is this. And we have expressed s ds by dt in terms of x and y. Okay.
Okay, sir.
One of them is given. We just need to find, two of them are already given. We just need to find it. Okay, ma?
Okay, sir.
Okay. So this is how we do related rates. Whatever one rate will be given, we have to relate that rate with some other rate. Okay.
Yes, sir. Understood.
I'll send you this book also.
Yes,
Okay.
sir.
Just keep it as a reference. Okay.
Yes,
So similarly, this one also. I think we have to relate this x and this z. Okay. And Pythagoras theorem, this square plus this square equals to this square. That's what we are doing. Okay.
okay, sir.
Okay. So what you do some this one. Your book is there, no? Either your handbook or this thing.
Okay, sir.
Okay, set. Okay. You try to finish up those, then we'll move to the JEE questions. Okay.
Okay.
So first I want to cover the topics and then I want to move to the JEE piece. We have related rates here and inverse functions we have covered, no?
Yes, sir.
Inverse functions we have covered. Then little bit of optimizations is what we have to do. There is one Rolle's theorem and Lagrange's mean value theorem. These two
Hmm.
theorems are important. Okay. And these two theorems, once we'll cover, then I think we can get into the three vectors. Okay. These two theorems are there. Before integration.
Okay, sir.
Okay. How good are you in integration and differentiation? Tell me.
Sir, it's like basic things which have like direct formula. Those are
Differentiation is easy. Differentiation is taking one function at a time and then keep differentiating, right?
yes, sir.